showing you what can happen. Okay, conducted in 1996 at the Paul Gooding High Power Laboratory, sensors were installed on both mannequins to measure temperature, pressure, and sound level. This is going to illustrate two people working on this equipment. Okay, the subjects were wearing cotton clothing, safety glasses, hard hats, and leather work gloves, which is pretty minimal protective equipment. Okay, we're going to go through 3 tests, starting with the most dangerous and working our ways down. Okay, first one, we have a size 1 combo starter with a 30 amp fuse switch. Load side, we're going to place a screwdriver face C to ground, and this test interrupted at 6 cycles, half of the standard. As you can see, the explosion was a maximum explosion. This is a category 3 or category 4 arc flash explosion, which is going to not only affect these mannequins by the flame that's erupting here, but also by the sound wave that's going to be caused by it, and by the blast that's going to be putting pressure on their chest and bodies. They're engulfed in the arc blast, or even the helper mannequin in the background was also affected, even though he was several feet away. Okay, here's an illustration on where the pounds per square feet, decibel levels, temperature ratings on different places on this mannequin's body. Okay, the worker would have over 6,000 pounds of force against his chest, violently pushing backwards and damaging his lungs to where the lung damage, the threshold for lung damage is up to 2160 pounds per foot squared. So with 6,000 pounds of force, this would probably even collapse his lungs. There is a high probability that eardrum damage would occur with 141.5 decibels at 2 feet. 720 pounds per feet squared is the threshold for eardrum rupture. So along with the force that's acting on it, the sound is going to damage them as well. Hands and neck have serious burns, while the chest should have no skin damage because he was wearing a shirt. An incurable skin burn occurs at 205 degrees Fahrenheit for 1 second. This put 437 degrees Fahrenheit on his hands, 122 on his chest, and 437 on his face. Now in the stage 2 test, we changed it. We kept the size 1 combo starter with a 30 amp fuse switch, still load side screwdriver face C to ground, but now we have a class L fuse in place of a 640 amp power circuit breaker. As you can see, the damage is very, very less from before. The blast covers the man's arm and chest, but not even close to the explosion we saw in the first test. It is greatly reduced because the fault is cleared in less than a fourth of a cycle compared to 6 cycles. Now this worker would have approximately 1,500 pounds of force against his chest, still pushing him backwards, but causing less internal damage since the bottom of that threshold is about 1,700 pounds. There's still a probability that some hearing damage would occur at 133 decibels. That's down from 141 in the last test. But the pressure that's against him is much less, so that wouldn't affect his eardrum rupture as much. The hands would have serious burns, but the neck and torso would not be burned. As you could have seen whenever the explosion happened, it was mainly on his hands and arm, and not so much on his chest and face. And finally, the safest of this, we're still with the combo starter, the size 1 combo starter, and we're still placing the screwdriver face C to ground. But the fuse closest to the fault is going to open first. And this is what we want to happen in any arc flash incident. There's going to be no change in ambient conditions that's noted because the 30 amp fuse opens, and opposed to the 601 amp fuse that opened test 3. So our first fuse opened instead of our second fuse, which took away all of the damage because the arc didn't get to continue on for a longer cycle. Okay, here are our conclusions of stage tests. Similar tests were conducted on larger starters, and MCCs were more violent in nature. Personal protective equipment can provide some protection against burns, but may provide minimal protection from the explosion pressure and the shrapnel that's going to be accompanying this pressure. Proper coordination and current limiting devices can reduce damage due to the arc fault energy, as we saw in the last one, which had basically no damage to the mannequins, where the proper coordination was taken. Here's some clearing times for some overcurrent protective devices, OCPs. As you can see, we have just some different tape or different kinds of overcurrent protective devices, some opening times at 8x and some opening times at 20x, just to show you kind of what the trip settings are on our medium voltage breakers, where trip setting is from, it's going to be over 5 to 20 seconds, but when you get down to the nearest ones where you have current limiting fuses, you're only looking at 1 second. That can greatly reduce if it acts first, if the fuse at the top acts first instead of the one at the bottom. So we're going to go through some arc flash regulations. This is from the NEC 2005 version. Some points here that I want to bring out is that industrial control panels covers almost every enclosure with an exposed energized conductor component. Okay, I'm just going to read this thing on the side here so you guys can get a feel for it. Switchboards, panel boards, and industrial control panels and motor control centers that are in other dwelling occupancies and are likely to require examination, adjustment, servicing, or maintenance while energized shall be field marked to warn qualified persons of potential electric arc flash hazards. The marking shall be located so as to be clearly visible to qualified persons before examination, adjustment, servicing, or maintaining of the equipment. So it would be prudent to label all the enclosure doors, removable doors. What kind of label do we want to put on? Okay, here are 2 other points before we get to the label, is that these fine point notes are non-enforceable, but can be taken as a sign that the NEC is moving towards this. The standard for electrical safety in the workplace provides assistance in determining the severity of potential exposure, planning safe work practices, and selective personal protective equipment. And the second fine point note is that product safety signs and labels provide guidelines for the design of safety signs and labels for application to products. And what it's saying is that the top label here is sufficient by code, but we're pushing to get down to this bottom label where we have all of the device information directly on it so that employees can see that right from the start. Okay, Part 1 contains general requirements for electrical installations. This is the NFPA 70E requirements. Part 2 contains general requirements for electrical work practices, including working on or near energized parts. Okay, there's Part 2 right there. It says, it states that a flash hazard analysis must be performed in order to determine the level of hazard and appropriate PPE for given tasks. The NFPA 70E is referenced in OSHA 1910.333. Here is Part 1910, Subpart S, standard number 1910.333 of the OSHA standards. Before opening any enclosures that may contain energized parts or equipment, every power source over 50 volts must be disconnected and appropriate lockout-tagout procedures initiated. After the enclosure is opened, a qualified person wearing suitable PPE must use appropriate test equipment to test all exposed parts to ensure that all exposed parts are electrically safe. Now there are exceptions to this rule, otherwise you would have to turn off all equipment before working on it all the time. The exceptions are, if a greater hazard will be created by de-energizing the equipment, such as disconnecting ventilation to a hazardous area. If access to energized equipment is required to perform voltage, current, or other tests, you need to have it on so that this person, but the person conducting these tests must be qualified with the company that hires and more employs him. And lastly, a qualified person has documented training in the hazards of working on energized equipment in general and has been trained on the hazards of the particular equipment to be serviced. Okay, this training must include the use of proper applications of PPE. Now, there's several approach boundaries based on the employee's training. This is going into a qualified, or this is going to tell you what a qualified or an unqualified person can do. There are limited approach boundaries, restricted approach boundaries, and prohibited approach boundaries based on the voltage of the energized equipment. And then the flag protection boundary, which we went over briefly earlier, is based on the voltage available fault current by the time it takes for the upstream protective device to operate and clear the fault. Okay, we're going to start with the prohibited range, as you can see shown in the very bottom of that equipment. That black box there illustrates it. Shock protection boundary to be crossed by only qualified persons, which when crossed by a body, part, or object requires the same protection as if direct contact is made with the live part. Okay, to cross this boundary and enter this space, a qualified worker must have specific training to work on energized components and have a documented plan justifying the need to perform this work. Here are the voltage levels, 0 to 50 volts. There's no prohibited approach boundary specified. From 51 to 300 volts, you have to avoid contact, and up to 750 volts, you can be within 1 inch. Now, the restricted range is a shock protection boundary to be crossed only by qualified persons, with, due to its proximity to a shock hazard, requires the use of shock protection techniques and equipment when crossed. To cross this boundary and enter the space, a qualified worker must have specific training to work on energized components, have a documented plan approved by management, and plan all work to keep out of the restricted range. Again, from 0 to 50 volts, there is no restricted approach boundary. From 51 to 300, to be 3 foot 6 inches, and up to 750 volts, it's 3 foot 6 inches. Last, we have our limited range for a shock protection boundary. To be crossed by only qualified persons, which is not to be crossed by an unqualified person unless escorted by a qualified person. Qualified individuals need only appropriate training and PPE to cross this boundary. Any conductive tool used by an unqualified person must not enter this area. And again, with no limited approach boundary at the 0 to 50 volt range, the two higher ranges are 10 foot away. This is the range that any unqualified person can be in with a qualified person. Clear up that first part. Okay, employees shall use insulated tools and/or handling equipment when working inside the limited approach boundary of live parts where tools or handling equipment might make contact. In this OSHA standard, employees shall wear non-conductive head protection where there is a danger of head injury from electrical shock or burns due to contact with live or exposed parts. And they shall wear protective equipment for the eyes and face whenever there is danger to injury to these areas from electrical arcs or flashes from from flying objects resulting in an electrical explosion. Okay, lastly, we have the flash protection boundary. The closest approach boundary, or the closest approach by qualified or unqualified persons without PPE. This distance is set at 4 feet for the systems between 50 and 600 volts. It may be reduced to a distance where a worker could be exposed to 1.2 calories per centimeter squared for 0.1 seconds. Now the reason it says that is if you have a correct arc flash study, there will be more specific flash protection boundaries labeled in our binders, or in binders and on the equipment. The available incident energy depends on voltage, available fault current, and the time that the current protection of the device to clear the fault. It is normally worth the trouble to calculate the incident energy because it forces the facility to examine its OCPD's coordination as well as preventing overprotective or